The de-rustifying is proceeding smoothly. Right now I have the piece that the transformer mounts to soaking in evapor-rust. So I thought I would take this time to see what we can do about this transformer. So these wires are very brittle and the insulation is crumbling. So I said before, the simplest thing to do is to simply slide some spaghetti tubing or heat shrink tubing over the wires. But I also wouldn't mind repainting this. On the bottom side, bottom half of the clamshell, it's in pretty good condition, just dirty. Laminations, a little bit of light surface corrosion. Okay, yeah. The wires go down into the laminations and then get pretty well buried in there. So I thought there might be, I've seen some where they have, you can kind of see where the wires get attached to the transformers and you could replace them fairly easily. What I could do though is clip these off short inside here, splice some new wires, heat shrink tubing over, and then run the new wires out. So just do not like how frayed and shoot up some of these wires are. Now if I do put new wires on, I need to pay attention to the gauge. For example, these two are the filament winding 6.3 volt. And look to be probably 16 gauge, something like that. So a simple thing to use for that would be like some lamp cord, which are typically 16 gauge, I think. And probably use something similar for the primary. Is it probably 18 gauge for the primary, 16 gauge or 14 gauge for the filament winding, and these other two, the center tap and B+, 18 gauge should be fine. And of course, when I got this off, I can clean it up. Very little corrosion on this. Here's the transformer with some new wiring. I used reproduction cloth covered for the primary, and center tap of this high voltage secondary, and the rectified B+ coming out. The two heavier gauge 6.3 volt filament are in pretty good shape, so I just left them there and slid heat shrink tubing over the entire length, and they were originally black, so that's fine. And the others, white for the primary, blue for B+, and yellow with green tracers for the center tap. I just went with the yellow. I suppose I could take a marker and put some green stripes on there if I really cared to. Alright, so that is all done, and now I will proceed to clean up the clamshells and repaint them. I've been saying the transformer covers, getting the corrosion off and any loose paint in preparation for putting some primer on. This side was especially bad, not surprising, because this is what faces up. The side that faces down was much cleaner and less corrosion. And I know I said earlier I wasn't going to mess with popping this part off, but I changed my mind. It actually wasn't too hard. Just used some flat nose pliers and bent those pins a little bit, and this is coming right off. And we've got the socket here. I'm not sure where things go from here. Okay, that lifts off. Question is there enough slack on these wires that we can kind of twist it around and get the transformer cover off? don't want to unsolder if I don't have to. Yes, I think maybe, just maybe, there's enough. There we go. Alright, cool. Yeah, good, because now I can get in here. Or it looks like there's some paint that never got put on that spot and it's corroding. And I can get in all around the inside lip there. And here's what that socket looks like. A bit of insulating material around here, and so 2 of these wires will be the secondary, high voltage secondary going to the plates of the rectifier tube, and the other 2 will be the 5 volt filament for the rectifier tube. Alright, so now I can really clean these up well and paint them, and for this I've just been lightly sanding the edges of the sides of the plates here, and I will brush this. I got a can of Rust-Oleum flat black paint. Brush that on. It saves with the hassle having to mask all this off to spray it. These I will spray. I'm pretty much done removing all the corrosion from the main chassis. And as soon as the transformer paint dries, I will start reassembling these. So I'm going to start off with this guy. So power transformer goes right here. 2 filter capacitors. Mount those new sockets in here. So it should be a fun little project. So basically, rebuilding this radio is going to be, well, like building one from a kit, I suppose. Now, I was talking about that Candome bias resistor, which indeed I was able to just bend it over a little bit and it popped right out. The rivet just pulled right out of the hole. Well, I was thinking, yeah, I could remount that, but I also happen to have one of these guys on hand, which is a modern Ohmite adjustable power resistor. So, with this guy, you can loosen up the slider and dial in the tap on it. And this isn't quite the same as the original, but it's pretty darn close. So the original was 162 plus 25, so 187. This is a 220. It's probably close enough I could just use it as is and just do the same proportion on the slider, whatever percent over that is. Or I could put a resistor in parallel with this to knock the resistance down a little bit. Either way, it will mount right in here, and it'll look just like the one they show in the parts diagram. So that's what I think I will do. So it'll look very much like that guy. The paint on the transformer has dried, so I can start reassembling it. Figure start off with this bit. So we have 3 wires that go through each of the openings. These 3 and these 3. This will be the easier part, I think. The more challenging thing will be to get this back around that socket. So make sure these wires are arranged so that nothing's getting crushed. Alright. Even though I got a heat shrink tubing, these openings are more than large enough for the 3 wires, so no difficulties there. Alright. So I'm going to have to refer back to my photos to see whether this goes on this way or this way. Not that it really makes any difference, but I figure might as well get it as accurate as possible. I'm going to see exactly how this went as well. What? I studied my reference photos, which showed that these wires come out the transformer and go towards the tube sockets, and the Philco name should be over on this side. The transformer mut's right down here. Oh, and yes, I have installed those new tube sockets. I used little cap-headed Allen wrench screws. I think they give it a nice look. So, you need to get the socket back up in here, opposite of what I did before. I figured easier to get it out than to put it back in. That one side and then the other. Alrighty, I think that's how it goes. And then this cap goes down on top. And I need to spread over those little teeth again. Okay. Oh, for wondering what kind of paint I used, let's see. Of the stuff. Rust-Oleum high performance enamel, spray any angle, semi-gloss black. Pretty good stuff. Nice big can too, lasts a long time. Alright, so this seated down. And then I used flat Rust-Oleum I just painted on for the plates. So it's all looking pretty good. I suppose I'd be wise to check for continuity before I seal this thing back up. So as memory serves, I think these two are the 5-volt filament. Oh, maybe not, maybe it's these two. Ah, these two. Alright, and this is the center tap to the plates. So, that should... Oh, this guy, yep, there's one of them, 70 ohms or so, yep, close enough. And this guy. Cool. And the primary. I haven't stripped these back yet, so a little tough to get the ohmmeter leads on there. Primary continuity, and this is the 6.3 volt filament supply for all tubes. Good. Which leaves this guy. Which is the rectified output. So this should have continuity through to tube filament. Rectifier tube filament. Yep, alright. Good. I'll just spread these over. I think I'll screw the shell back together and then I'll bend those over. Saved all my hardware. I believe these are brass. I'm going to try cleaning up these heads a little. And I think I'll just replace those rusty washers. On this side. Alright. I'm just going to bend those little things over. I think I will use a nail set and a hammer. I have a nail set right here. Okay. Bend them kind of over and out at the same time. That side's good. Do a couple more whacks on this side. I got it. And measure. Alright, I ain't going anywhere. And there's a rectifier tube. Just needs a little help. I'll test it before I bother to try repairing it, but if it is still good, a little glue. Looks like somebody may have put some glue down in there already, but you gotta use the right kind of glue. These tubes get really hot, and a lot of glues just are like super glue, will just fail from the heat. It'll start crystallizing and the bond will break. So this will get mounted. Like so. Ah, crap, just realized. I gotta take this back apart. Not these little things, luckily, but these two, because I forgot to put in the 4 screws that go through here. I knew I was gonna forget something. These buggers. Gotta put one of these in each corner. Oh, well, here we go. Take it apart again. Alright, so once I get that squared away, I'm going to start working on wiring this up. I am going to go with that Ohmite adjustable resistor for the bias. So we'll get that guy going down in here. And wire up these two guys, and the filter capacitors. So we've got the originals dried out and no good, but since they are here and they're in pretty good cosmetic condition, I figure great candidates for restuffing, and then that's where the new filter caps will go right inside here. The only drag is that whoever worked on this before kind of killed them. Killed the terminals. Looks like these just got mashed flat, so maybe I can reuse them. And then this one just got cut off. Well, this is still here. So what I do on this type, cut it with a real sharp blade right below that lip. A real sharp utility knife. It's just aluminum, real sharp steel, no problem cutting through that. The pop just comes off, take the insides out, knock this out, run 2 wires to the electrolytic right through the bottom, and you can pop this cap back on with a variety of things with a friction fit or a little glue to hold it back on. These types, cut it right about here. Then when you put the cardboard and the clamp back on, it holds the 2 halves together. Use a little bit of aluminum duct tape for extra strength, and then this covers up the seam and you're good to go. There's 2 suction cap with the outer ground. In fact, the outer on both of these is negative for the capacitor, but they do not go to the chassis. So rather than having to try to deal with attaching the new capacitor leads to the aluminum and then insulate it and all that, just drill a 3rd hole here, and I'll run 2 wires out through here. This outer can will just be floating, and it won't matter if it ever makes contact with the chassis or not. Alright, let's give this another try. Oh, and while I had it apart, I also reversed the screw and nuts because I realized that the nuts were bumping up to the end of the cutout there. So there really was a reason why the screws heads are on the bottom and not the top. Tough to get on with these wires here. I think I can manage. Okay. Seated nicely. Start putting these nuts and washers back on. Alright. Now, see about routing, or installing rather, that power resistor. So a couple things I want to do. One, I want to figure out what parallel resistance I should use to bridge this to get the exact value that was in there originally. Tighten this down in the correct position, and then dig up some mounting hardware so I can get down in there. Let's get a little tight down in here. So I think I'll see about wiring up these sockets before I install that if possible. After studying the original photos I had taken, I thought the best place to start would be wiring up these two sockets, or at least bias resistors and filament connections. These are the 6F6 push-pull output tubes, and I figure after I wire them up, then I can do this kind of stuff, because these wires are going to be going on top of these tube sockets. So I want to get them first. So if we take a look at the schematic, find those two tubes right here. But notice something immediately. There are no pin numbers on those tubes. So I looked them up in a tube manual and traced out the pinout. Got it right here. And the important thing to note is pin 1. 6F6 comes in 3 styles: metal, and G for glass, and GT for another glass variant type. Now, if you have the metal, pin 1 is shield, which would normally be ground, and in some circuits that originally used the G or GT, they may have that pin 1 going to something else, because it's an unused pin, just like pin 6, and use those for tie points for their components. Another thing to note is heater. We've got on pins 2 and 7, and the cathode and G3 is pin 8. If you notice on this schematic, no mention of a shield, and they got cathode going directly to one of the filament sides. Well, which one? Is it pin 2 or is it pin 7? Well, luckily, I took reference photos, so I know. And it's not what you might think. Just look. Well, you might think, hey, the most logical thing to do is to tie pins 7 and 8 together and ground it. Especially when you look at the way these sockets are laid out. And with the type of sockets I use that have ground lugs on them. Here's 7 and 8 right here, and there's a grounding lug. I can just tie all those 3 together, bam, done. That's not how they did it though. They actually connected the other side. So they have 2 connected to 8, and they also connect 1, so they shorted these 3 pins together. So if you were to use a metal type, that'd be cool, because it would be grounded. But I don't think that's what they used originally. RCA, I believe, pioneered those metal tubes, and Philco would not have used them. They would have used glass tubes. And if you don't know, the numbering scheme for tube sockets goes clockwise when you look from the bottom, from the key. So here's the key over here, and this is pin 1. 2, 3, 4, and so on. And a little bit bonus with these sockets is they have numbers printed on them. If my camera would focus. So I can go off of those numbers, or just count around. So I want to connect pins on. What did I just say? I also went and wrote the pin numbers down. So pin 2 and 8. So 1, 2, and 8 go together. And that's also where one of these wires goes. One side of the filament wire goes directly to ground, and is common for all the tubes. And kind of just seeing how the wire is still naturally bent from when it was in its original position. I think it connected up over here. So I'll heat this up a little so it's more pliable again and kind of wrap it around. So 1, 2, and 8. So these 3 right here. I will use some bus wire for that, just like they had on the original. Some bare bus wire. Spool around here somewhere. There we go. Use this. And then the other filament wire will go to 7, which is over here. So these two kind of wrap around and go here and here. And then 2 wires come off of here and run. Oops, my batteries were running low. As I was saying, so we wire these 2 into the socket, and then 2 jumper over to here, and then 2 wires run off to the tube filaments, the rest of the radio. Or actually, not 2 wires over to here, just ground those 3. Run 1 wire over to here, and then 1 wire off from here to the other tubes. Then there are a few biasing resistors, also some coupling caps, but those are actually located on this board, I do believe. In fact, this might be those too. Those are 0.05 microfarad caps. I'll get to this later. First I want to wire what I can, which would be the components we can see on this handy diagram. Turn around. Let's see, like this. So we got 1, 2, 3, 4 resistors. I want to wire those 4 in and get those tube filament wires hooked up. And then so can kind of build this from the lowest level and build up. So I can see these dashed lines here. I want to get those components in, and then I'll install that bias resistor and hook up, rebuild that big light block, get that in here, the 2 filter caps, and once all that's done, then I'll do that board.